The one I think is messed up. The one question is definitely messed up. It's the first one, 22. They shouldn't have had those double thing. I don't think that's, I mean, I'm not going to expect you to do that. So I'm not going to worry about that one. So if you want to change that and try it again, I put it a plus sign. So for number 22, the second equation should have read x. Oh, you guys can't see. So the second equation should have read x plus 2y is greater than 0. That might be easier. First one's fine. Yeah, same thing. 0 is less than x, which is less than or equal to 125. Really, this is just two separate ones. They're just smashing it into one. You should be able to graph that. 0 is less than x, right? And x is less than or equal to 125. That means x is bigger than 0, so it's over here. But then I'd go to 125, which would, I'm going to say it's right here, and it would be less than that. So it's in between here. But then I have other ones to graph that would also cause restrictions. It's between 0 and 125. That's what I would do, between 0 and 125. You should be able to do that.
Also one of them is dashed.
Oh, you're correct. The first one would be dashed. So that would be tough. What I would do on that one is, so it's because it's on the origin, like he said, 0 is less than x. It should be a dashed. So I'd kind of get as close as I could, but I'd put a little dash mark on there, and that's good enough for me to know that it's that you're talking about 0, and it's just you need to draw it so we can see it. Okay, something like that. I don't know. Maybe on a test they would actually dash the line for that one. I don't think so. I've never recall seeing that. So, but I would just put it right next to it. X is less than or equal to 7. That means we'd go to 7. 1, 2, 3, 4, 5, 6, 7. This is where x is 7. Now you would draw a line if it was equal to, right? It's the same exact one. Yep, it's the same. It's going to be the same exact line. And then I decide whether it's dashed or dotted based on this guy. And then since x is less than it, it's going to be everything below it. So I would shade over here. That's part of 24. It's just part of it.
So for like x it's less than greater than 0, you just put 0 in for x, but then 0 is greater than 0. How does that work?
You don't have to put it. That one should be done. X is greater than 0. That means it's here or over. You don't need to test that side. The only one you need to test when you need to plug in a 0 or a, are you with me?
Yeah.
The only time you have to test is if you have two variables. If I say y has to be greater than 7, I'm going to go to the 7 on the y. 1, 2, 3, 4, 5, 6, 7, and it's here or above. There's no other variable that affects it, so I don't have to plug a point in. Do you get what I mean by that? Oh, let's do the word problems. First off, I know exactly what you guys do because I did the same thing, to be honest with you. I think part of the reason that maybe I'm a decent teacher, kind of an okay teacher, is because I can kind of remember what I did, and I try to help you guys out through those things so I can remember. And tell me if you did this. You looked at last night's homework. You just glance at it, right? You look and you see 22, and then you get to 26 and 27, and before you even really got your pencil out, you just looked at it. You went, "Oh crap." Yep, you did it. Yeah, I'm not. You and yep. Some of you even go, not doing that one. You didn't even give yourself a shot. You guys don't even give yourself a. Some of you don't. So here, I'm gonna take that away. We got to stop that. We got to stop it. First off, we got to stop freaking out when we see them, because there's a study that says this is true, that when you already say you can't do something, right? There's a great saying, okay? There's two types of people in this world. Those who say I can, and those who say I can't. And they're both right. What does that mean? Thank you. Whenever you tell yourself you can't do something, it's not fully always going to happen. But when you tell yourself you can't do something, you're probably going to make it to where you can't do it.
Okay, so then why do I say when I can't do something, I end up doing it? No, it doesn't happen. Whenever I say something's not going to happen, it does happen.
No. When you can't do something.
Yeah.
No.
Still.
No, not like something isn't going to happen. No, we're saying when you tell yourself like, I can't do this problem, and then you try it, you probably are not going to do the problem because you're not going to give it the effort. It has 100. It's true. You've got to start telling yourself you can do it. I can do this problem. Relax on these word problems. Stop freaking out because, like I said, most of you looked at these problems, you just saw it, and you already were like, nope, I'm probably not going to get that one right. That's got to stop. Seriously. And hopefully by us doing them together and talking about them and making them not so scary, it will be easier to do that. So I'm going to do 26 with you, and then you're going to try 27 on your own. So you should probably have your books out, the things that you're supposed to bring with you back and forth. This, you should have this out.
Can you do 27 instead of 26?
Nope. 27 is actually easier. Yep. So we'll do 26. And then you'll do 27, and we'll try it, and then we're going to do it together. But I told you something at the beginning of this chapter, and some of you thought, it's not that big a deal, but it's a huge deal, especially in word problems. I said something about if you have two variables, you have to have two equations to solve for it. I said if you have three variables, you have to have three equations. If you had four variables, you had to have four equations. Yes? Flo, are you with me?
Yes.
So when I read this problem, let's keep that in mind. So Charles has a collection of, first thing I would do, by the way, when I do a problem, just read the problem. Don't do anything in the beginning. Read the problem. And have you noticed in math class, I try to come up with a plan of attack. Have you noticed I say, hey, what do we have here? And then we start working with it. So that's kind of what we're doing. Okay, let's get a plan of attack here. So he's got a collection of dimes and quarters worth $1.25. He has 8 coins. Write a system of equation that represents a situation, then solve to determine how many dimes and quarters he has. So what's the end goal? What am I trying to solve for? Dimes and quarters. How many variables is that? What does that tell me now that I just told you something a second ago? So I've got to read this word problem and somehow come up with two equations. All right, let's talk not word problem right now. If I asked you how much money you had, and you had dimes and quarters only, how would you figure out how much money you had? Would you just seriously just add? Would you go 25, 50, 75? Or if I said you had 10 quarters, how much money do you have in quarters? And how did you get that? Or you could do 0.25 times 10. Repeated addition is called multiplication, right? So how could we figure out how much money this guy has when he has quarters and dimes only? We can't add them now. Repeated addition is called multiplication, right? So how much is a dime, or how much is a quarter worth? So 0.25, and how many quarters does he have? So we call that, and I'm going to use Q instead. Why did I use Q? So word problem helps me remember that these are the quarters, because if I use X, I don't know that X represents quarters instead of dimes, and I might get them mixed up. So I use things that remind me of what they are in the word problem. There's no reason X and Y doesn't have to be X and Y. You can change it. Okay, make sense? And we're going to add how much he has in quarters to how much he has in dimes. How much does he have in dimes? Well, how much does he have in quarters? Yeah, we do. 0.25. Hold on. How much does he have in quarters? Yes, we do. 0.25 times Q would tell us how much he has in quarters. We would take 0.25 and times it by how many quarters there are. That would be how much money he has in quarters. If he had 10, he'd have 250. If he only had 2 quarters, he had 50 cents. That right there would tell us how much he has in quarters. What? Because when you take 0.25 and you times it by Q, that tells you how much you have. We don't know how much he has in quarters, so that's why it's Q. But that would tell us how much he would have. So how much would tell us how much he has in dimes? 0.1 times D. And how much money does he have when we add those two together? $1.25. That's one equation. This is how much he has in quarters. This is how much he has in dimes. We add those together, and that's how much he should get for a total. Repeated addition is called multiplication. Does everybody understand that first equation? Now we got to come up with a second equation. It says he has 8 coins. What are the only types of coins he has? So how many quarters does he have? According to what we did up there. No, 0.25 is the value of each quarter. What does Q represent? How many quarters he has? So how many quarters does he have? Q quarters. Plus, how many dimes does he have? Because that represents how many dimes he has. And that should equal 8. He has 8 coins total. If I said he has 3 quarters and 5 dimes, doesn't that add up to 8 coins total? Do you see how I came up with 2 equations to get these? Now, once I have these 2, I can start doing what we did before. Now, it's not as easy as this one, because I don't like doing, I mean, I guess I could times by a -4, and that would get me to some stuff that I could, you guys get what I'm talking about? Well, right now I made the equation. Now what do I have to do? And how do I solve? What are the 2 ways that I can solve for it? Elimination or, so that's what I'm working on, is I'm going, okay, how could I eliminate them? If I times this by -4, what's 0.25 times -4? -1. And why would I want to make that become -1? You're freaking out. You're not even, you're where are you at right now? Yep. What part? Because you're not where I need to be. You're not with me. You're behind. Where are you at? Don't do that, because you could do that with this one. But that's not how you're going to do when I give you, he has 25 coins. So we have to do it the right way. The right way is to use substitution or elimination. And the way we do that is we have to make one of those variables become the other one. And I'm telling you, I could times this by a -4, because then a 0.25 times 4 is 1. That would make the Q be a -1. This is really a positive 1Q, and they would cancel out. However, I don't want to do that. I don't want to deal with the decimals. It is possible, but I don't want to deal with them. So remember how I can times by any number I want to in the world? There's a number that actually allows you to get rid of the decimals. What number moves decimal places? Tens. Well, if not anything ending in 0, because if I times it by 20, it doubles it and then moves the decimal place, if you understand what I just said. Multiplying by a 10 only moves the decimal place. So like if I had 5.43 times 10, that turns to 54.3. It just moves the decimal place. However many zeros there are. That's the rule for multiplication by 10, yes? So how many decimal places do I want this thing to move? 2. So what would I multiply it by? And if I multiply it by 100, all that's doing is allowing me not to have decimal places anymore. It's just a trick because I don't like the decimal places. So I'm going to move this decimal place twice, and that's going to turn into 25Q plus move the decimal place twice. It's going to turn into a 10. Move the decimal place here. Move it one more time. Since there's nothing above it, I got to put a 0. And then the next one turns into 125. Does that make sense? But now I gotta do the second one by something. You could do negative 25. Which one would you choose now? Why? Yes. Does everybody understand? He's going, hey, I need to technically, if you like substitution, could you do substitution here? Yes. Do you guys understand what I'm talking about? I'm not feeling like we're getting this. This is exactly what we've talked about for the last 2 or 3 days. Substitution or elimination to get rid of one of those variables. And I could substitute this by going, hey, minus d to both sides. I got q equals negative d plus 8. I could do substitution if I wanted to, but I don't like substitution. And since it's my choice, I'm going to do elimination for this problem. And since he said I could make this right here, this is a q, this is a positive 25q. If I made this a negative 25q's, the q's would eliminate. But he said 25 is a pretty big number. Let's see, what would I have to multiply the d by? And he says, hey, if I multiply it by a negative 10, then the d's cancel out. This turns into a negative 10q minus 10d equals negative 80. Positive 10d and negative 10d, they cancel out, eliminate. When I combine these, I'm left with a 15q equals 45. When I combine those two, this and this, divide by 15, divide by 15, q equals 3. I then substitute q in right here, and I get 3 plus d equals 8. I minus 3, I minus 3, and I get d equals 5. So he had 5 dimes and 3/4. I want you to try this one real quick. Set it up and then you can. Are you in? Do you have your book right there? Yeah. Go to your pages. Bring it to me. I'll show you. I'll show you how to read it. Oh my goodness. Okay, look. See how it says that? So we're on 1/6. So you're gonna go all the way to 1/6. And then 27. 27 is the one you should try on your own real quick. Look at yours. If you're online, you should be looking at your book. Online, page 20, numbers 27 from homework last night. I want you to try to come up with the equations. Remember, read the problem first. Find out what they're asking. And then try to find out how to get that answer. Josh, I love that you're answering, but go ahead and just say it out loud. I don't mind if it interrupts.
Oh, what's from the last one?
Yeah, no, I know. So I'm telling you, go ahead, unmute and talk, because I'd rather you participate like that. I appreciate you participating.
All right, thanks.
All right, what'd you get? Good. Anyone get 20 and 30s? 20 and 30? No? Did you solve it or did you just set it up? All right, let's try to do it. First one. Let's read. Elise, you tap her. Tap her. It's okay. Come on, wake it up. All right, so when we do this, we're gonna read it. A set of triangles and square tiles contains 50 pieces and 170 sides. So it has triangles and squares. Write a system of equations to represent the situation. Then solve the system to determine how many triangles and how many square tiles there are. Okay, first thing, what are we looking for? How many what?
How many squares?
How many squares and how many triangles are in there? You with me? So if I'm trying to find that, those are two variables. Colin, you with me? So how many equations do I need? 2, yes? So, Colin, how many pieces are in this? 50. And how many types of pieces are there? Okay, what are they? What? What'd you say? No, you're on the right track. Okay, so what would we use for how many triangles there are? So T plus, what do you think we're going to use for squares? And how many are there total pieces in there? So however many triangles there are, plus however many squares there are, has to equal 50 pieces, yes? Does that make sense? Daisy, how we doing? Now, there are 170 sides total. Well, how many does each triangle count? 3. How many does each square count for? Do you follow me? So, how many, what would I do to figure out how much there are for sides? I would say 3t, good, plus 4s equals 170. Now the rest of the problem is what we've done in the past, where we're going to say, hey, I need to get rid of one of my variables. Which variable do you want to get rid of? Well, what variable? T. I'd get rid of t. Why would I get rid of t? Just because I only have to multiply by a -3 instead of a -4. Not a big deal. I just always pick the smaller number. So if I times by a -3, this turns into -3t minus 3s equals a -150. 3t plus 4s equals 170. Sorry, my handwriting, I'm trying the best I can. It's hard with this screen the way it is. That cancels out, leaves me with 1s equals 20. Once I figure out that s is 20, I can plug that in right here, and I can say t plus 20 equals 50. I minus 20. I minus 20. T equals 30. Boom. Done. Does that make sense? Yes.
For 50, did you just do like 10 times 50 to get to 150?
When you multiply by 3, you have to multiply everything in that by 3. So you have to multiply this by 3, this by 3, and that by 3. To be fair. To be fair. Questions on that? Good? All right, try it with this one. Again, I need more effort. This side over here, I need something talking to. These guys over here, I know are getting it. You guys over there, I have no idea where you're at. I need you to start talking. Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. His goal is to earn at least 200. You're not going to find it. It's in my book. The goal is for him to earn at least 200 each week, but he can only work a maximum of 20 hours per week. He also must walk the dog at least 5 hours per week. I'm going to read it again. I'm just kind of giving you the idea. So remember, we're just reading right now. So he's got a lot going on. So he earns $20 per hour mowing lawns. He earns $10 per hour and wants to make at least $200. There is definitely an inequality that can be done by doing that equation. So, someone come up with an equation for that one? How do you figure out how much money you make if you go to work? You better learn how to do this. No, you better check them because let me tell you what, they make mistakes. Credit card bills make mistakes. You better know how to do this or, huh? Yeah, they make mistakes too. It's on a pay stub, but the pay stubs, but sometimes they make mistakes, is what I'm telling you. But it can be wrong. You know your credit card bills online too? It can be wrong. All of it can be wrong. Because it's someone who's inputting the hours in there to make the machine do it. So if they input your hours wrong, then you're going to get not the right pay. So you should be checking to make sure that you're getting the right. So how do you figure out how much you get paid? So if he's going to do $20 for every hour he works mowing yards, do we know how many hours he spends mowing yards? No. So he's going to get $20 per yards, but it's not yard cut. It's $20 per hour he spends cutting yards. It's a little different. It's not how many yards. He doesn't do $20 for a yard. So if a yard takes him 2 hours, he charges him $40. So it's $20. So L is how many hours he spends cutting yards. $20 per hour?
But it don't take you an hour to cut yard.
That's a great job.
You don't, no, I'm saying, so does he get paid by a company or the person who cut yard?
It doesn't matter. He makes $20 an hour.
But what if you only?
That's more money than you ain't gonna find a job making $20 an hour.
What if you cut grass? But like it only take 30 minutes. How much they get paid?
$10.
Not even, no.
You got to get more yards.
No, I would set like a rate, like whenever I'm done, then I get that much. I know what he's saying.
I get what you're saying, but he does $20 for an hour.
That's good.
That's really good per hour.
It depends.
You're right. I get what you're saying, because if you don't get enough jobs, then you're not making enough money. You'd rather pay maybe less per hour, but you get more hours. I get, there's always a balance in finding this, but this is his question. But I get you in real life. But he's working $20 per hour for when he mows yards. He only charges $10 per hour when he's walking dogs. So he's add $10 for every hour he walks the dogs. And we want this together to be, when you add that together, we want that greater than or equal to what? $200. Well, he can work a maximum of 20 hours a week. That's it.
Only 20. See, that's
What his mom and dad said. You can only work 20 hours.
Oh.
I don't care how you do it, but you can mow yards, you can walk dogs, but you can't do more than 20 hours because you got schoolwork. So, but he can't get that many yards. And his neighbor said in order to walk this dog, you got to walk five hours a minimum. We're going to get to there. It's in the word problem. But let's get to this part. How can we figure out how much he can work? L plus, not 5D, L plus W has to be less than or equal to 20 hours. However many hours he spends cutting yards, however many hours he spends walking dogs, has to be less than 20. We'll get to that in just a second. Because this is the total hours he does yards, this is the total hours, this is the total hours he works. Because those are the only two things he can do. And it has to be less than or equal to 20. Now his walking dogs, he has to walk the dog at least 5 hours. What does that mean? That the hours he spends walking has to be greater than or equal to 5 hours. Yeah. we got to break it down. That's why we're taking it sentence by sentence and saying, what does that mean? And talking real life, like thinking it through. If I make $20 per hour, what does that mean? You take 20 and times it by how many hours? That's what I did. That's what I did to find this first one. Just 20 times the amount of hours he cuts mowing grass.
This is phase 4 of
$10 for however many hours he does for walking dogs.
B, and E hall.
Just break them down. The more you're doing, the better you have.
Evacuate to their appropriate area of refuge at the perimeter of
Now,
the campus.
because
Students, please bring your belongings. Once you reach the area of refuge, you may continue to your next class period as directed by your teacher. There will not be a bell or call to return to campus. Once again, odd classes in B, D, and E hall, as well as the front office.
now, these are inequalities, correct? I did not show you how to do these algebraically. So what would you have to do to solve these? What was the way I showed you how to solve inequalities? No. What was the way I told you how to graph to solve these? I keep saying the word. By graphing it. Now, some of you are looking at it going, wait, hold on. I don't see X's and Y's. Make the W make the L your X axis and make the W your Y axis. It doesn't, I mean, you can make this, you could say, hey, this is W and this is L. So, and then you do the same thing. We would find, what form is this in? Standard form. So I'm going to find X and Y intercept, right? So my intercept would be for the L's. Since L is my X, it would be, I'd be plugging in 0 for W. So it would be 10, 0. And the other one would be 0, 20. So 20, 10. It's a solid line. Does that make sense? And it has to be greater than, so if I plug in 0, is 0 greater than 200? Nope, so it's this side. And then 20, 0, and 10, 0. Huh? No, you were right. Yep, because you plug in 0, so it'd be 20, 0, 20, 0, so it'd look like that. The other one would be a line across here, and it would be all the spots in between there. Make sure you go over this stuff. We have a review tomorrow. We're going to do, tomorrow you're going to do the review in class. We'll go over the review. You have a test Friday.
Friday? Come on, not a Friday.
Test Friday. You're doing the review in class, and then we'll go over it in class, and then you have the test on Friday.
I'm just so tired.
Bye, guys. Have a good day. Tonight, you can go